So we are going to look into a specific case, but very useful case of division called as synthetic division. It is sort of a mechanical process, but the only caveat of this particular method is it'll only work if the divisor is of the form x minus some number. So the divisor has to be of the form x minus some number. Otherwise, we cannot use synthetic division. One may ask, what if we had x plus c? Well, that's not a big deal at all. So I could write x plus c as x minus of minus c. So I still have x minus the requirement, but only in this case we have a negative number, negative c. So even though we always say synthetic division works only if the divisor is x minus 3, we could also use x plus c. We just have to rearrange the terms a bit. Okay, so what is the process? So it's best to explain this using an example. So we're going to divide x squared plus 3x minus 40 by x minus 5. So oh, that's messy. So what I'm going to do is I am going to write the coefficients of each term. So x squared, the coefficient is 1, 3, the coefficient of x, minus 40, the number. And I'm going to put the number c that I have in my, the number 5 that I have in the divisor on the side right here. Oops. So the very first step is to bring that 1 down. Next, we multiply 5 and 1 and put that product over there. So that will give us 5. Now, when compared to long division, synthetic division is easy, but there are subtle differences. One of those differences is we always add and not subtract. If we look at long division, at every step I subtracted, but here we're just going to add. So 3 plus 5 is 8. Now I am going to take the 5 and multiply with 8. Whatever answer I get, I'm going to put it in there. So 5 times 8 is 40. I'm going to add, so negative 40, positive 40, I get 0. The last term, I just box it in such a manner. So what does this mean? This simply means that the remainder is 0. So the remainder is right here. The quotient, since we have x squared in the problem, we're going to start with x and then decrease the powers. easier way to remember is look at the numerator polynomial. It is x squared. The denominator polynomial is x. If you divide x squared by x, you have x. So we've got to start with x. So I'm going to put x. Naturally, the next one would be a number. So I take the coefficients over here and put them right next to the terms. So x raised 1, the next term is x raised 0. So I put 1, the first coefficient, and 8, the second coefficient. And x raised 1 is just x. X times 1 is x. X raised 0 is 1. So 8 times 1 is 8. So the quotient here is x plus 8. So we want to divide x squared plus 5x minus 6 by x plus 6 using synthetic division. But before we proceed, we've got to recognize that the denominator has to be changed because we require x minus 6. So x minus of minus 6. So the number here will be negative 6, which we will be using in our synthetic division. So I put the coefficients, so 1, 5, and negative 6. So the number is negative 6. If I bring the 1 down, I have 1. Negative 6 times 1 is negative 6. But we've got to keep in mind that we always add when it comes to synthetic division. So 5 plus minus 6 is minus 1. Negative 6 times negative 1 is positive 6. And if we add, we get 0. So the remainder is 0. The quotient, since we started with x squared, the first term must be x, x raised 1. The next must be x raised 0. So the coefficients are 1 and negative 1. So 1 goes here, negative 1 goes there. So negative 1 times x is negative x. Negative 1 times x raised 0 is simply negative 1. Sorry, that should be a positive x. So the quotient is x minus 1. I was looking in the wrong place. So we have x minus 2 as required by synthetic division. So I'm just going to write the coefficients. So 1, minus 14, and 24. 2 goes up there. If I bring 1 down, I can multiply 2 and 1. And that will give me 2. We always add, when it comes to synthetic division, negative 14 plus 2 is negative 12. 2 times negative 12 is negative 24. So when we add, we get 0. So the remainder is 0. The quotient, we start with x raised 1 because the original problem started with x squared. So decreasing powers, I just write them down. Put the coefficients 1 and minus 12 in order. So we have 1 times x raised 1, which is x. Negative 12 times x raised 0. X raised 0 is 1. So we will have negative 12. So the quotient is x minus 12. So we want to divide x squared plus 12x plus 32 by x plus 4 using synthetic division. So I'm going to write the coefficients 1, 12, and 32. We require the form x minus something, so I'm going to write it as x minus of minus 4. Minus 4 goes up there. 1 comes down, negative 4 times 1 is negative 4. We always add with synthetic division. 12 plus minus 4 is 8. We multiply 8 with the negative 4, we get negative 32. When we add, we'll end up with 0. So the remainder is 0. The quotient would be x raised 1 plus x raised 0, and we fill in the coefficients. So 1 and 8. X raised 1 is just x raised 0 is 1, and 8 times 1 is 8. So the quotient is x plus 8. So we have x cubed plus 6x squared plus 4x minus 7. Going to write down the coefficients. And since I require, x minus something, I could write x plus 5 as x minus of minus 5. So minus 5 would go up there. 1 comes down. Negative 5 times 1 is negative 5. We always add. 6 minus 5 is 1. Negative 5 times 1 is negative 5. 4 plus negative 5 is negative 1. Negative 5 times negative 1 is positive 5. When we add, we get minus 2. As always, the remainder here is negative 2. But before we move on to the quotient or writing it down, we've got to keep in mind that if the numerator starts with the degree 3, the quotient must start with 2. If the degree of the numerator is 4, the quotient must start at 3, and so forth. So since we have x cubed, I'm going to start with x squared, followed by x raised 1, followed by x raised 0, decreasing powers of x. So the coefficients now are 1, 1, minus 1. So 1, 1, minus 1. 1 times x squared is x squared. 1 times x is x. Negative 1 times x raised 0 is simply negative 1. So the quotient is x squared plus x minus 1.